Okay, now we're going to reverse this. Oh, no, we're not. So, silver, Ag, PO4. Remember, copper is always a +2, and silver is always a +1. So even though it's in this area where you have to get Roman numerals, you don't have to do it for those two. So Ag is silver, and PO4 means phosphate. Ooh, Y. We never used Y. Y is yttrium. And once again, you will notice if we look at this periodic table, yttrium is over here. You cannot look in the periodic table and determine what yttrium is. So therefore, we're going to need a Roman numeral there. And then we have ClO3. Which ClO3 is chlorate. I'm going to keep those in parentheses, so when I uncross it, that becomes a -1 and that becomes a +1. Notice I did not cross that 3, because that 3 is part of chlorate. And if you look up the polyatomic chlorate, you will notice that it's supposed to be a -1, which means that it was not reduced, which means that the yttrium is actually a +1. So I have a Roman numeral 1 there. SnS2, looking on the periodic table, Sn is 10, and you cannot determine, even though it's over here, that was the row that we skipped when we were doing numbers. That's because you can't determine what that row is just by simply looking. So we do need a Roman numeral there. And then sulfur becomes sulfide, because you take the root, the sulf, you uncross it, that becomes a +2, and this no number here becomes a -1. If you look at sulfur on the periodic table, it's supposed to be a -2. So that means that this must have been reduced. So I have to multiply both sides by 2. So it's not 10,2 sulfide, it's actually 10,4 sulfide. Okay. Ti is titanium. If we look on the periodic table, we find that titanium is right here. You cannot look at the periodic table and tell me what the charge is. Therefore, I need to figure out what the charge is supposed to be. I need a polyatomic ion there, or a Roman numeral there. Cn is a polyatomic ion that's cyanide. We uncross it. That's a +4 and a -1. When we look up cyanide, we realize that cyanide is supposed to be a -1. So that means it's okay. That means that 4 becomes a Roman numeral 4. And then finally, for finishing up this set, potassium is right here. So that means we can look on the periodic table and determine its charge. We do not need any Roman numerals. And MnO4 stands for permanganate. And you are done with that one because you don't need a Roman numeral there. And that's 11 through 15.